All right, welcome back, Patriots. This is Mr. Love, a.k.a. the Math Patriot, bringing you another fun and exciting, and this time very easy lesson in the fun and exciting world of high school geometry. All right, let's do this. What? Let you say it next time?
No, let's say hi.
Why do you want to say hi every time?
Because it is tradition. Just as much as your intro.
All right, you just wasted your time to say hi. Okay.
Hi. Hi. Hello there. Hello.
So, I need to start recording in front of a different class. All right. So over the last few weeks, we've done a lot of kind of disparate topics in geometry. Especially the last unit was all about transversals. And we are now finally getting to actual real shapes for the first time. In Unit 4, we had to do 3 units worth of randomness to finally get to a shape of some kind. So, now we're going to be doing triangles, but it's the very basics of triangles. Nothing today should be new. A lot of this was covered back in middle school geometry. So, you guys already know the vast majority of this. There's one thing that might be new, and I'll point that out when we actually get there. So, first off, we're going to be classifying a triangle, and we're going to do 2 different types of classifications. One of them is by angles, and the other one is by sides. So, first off, an acute triangle. An acute triangle is just a triangle in which all the angles are acute. Notice all 3 angles, are acute angles. All right, equiangular. Equiangular is exactly what it sounds like. Equal angles, equiangular. All triangles all angles in the triangle are congruent. Okay? So, you're used to the word equilateral. Okay? Equilateral triangles are also equiangular, and we'll get to that in a little bit. But just realize we use the word equiangular as like a vocabulary word, but it doesn't get used in most cases. We usually just say equilateral. Okay. Also, what? Oh, I forgot. You'll have to copy this down. I'm done copying them. I don't know if it's taking else along. I mean, yeah. Yeah. If you want to write there in lesson 90 for acute, that's fine. Something like that. All angles less than 90 degrees. All angles are congruent. Yeah. Okay. Still sequence is moving. This is the most exciting part of my videos ever. Letting my students copy their notes. We'll get there. No. No, we don't do boots and cats. We do it the right way around here. All right, okay, anymore.
That's your new intro.
Okay. All right, we've also got obtuse triangles. An obtuse triangle is a triangle with one obtuse angle. In this case, it's that one. The obtuse angle. A right triangle is a triangle with a right angle. This is like mind-blowing stuff, I know. Okay. The side opposite the right angle is called the hypotenuse. Now, identifying the hypotenuse is going to become extremely important in the next, a few units from now. I really hope that you can just look at a triangle and tell me where the hypotenuse is. Okay? Like, for example, let's do this one. Where's the hypotenuse? Left, right, or top?
Right.
That one right there, right?
Yes.
Okay. All right. What if I changed it around and did this? Where's the hypotenuse?
Right.
Yeah, that right-hand side, that one right there. Okay. Identifying the hypotenuse is extremely important. For now, the other 2 sides, the ones that make the right angle, those are just called legs. When we get to trigonometry, we'll learn 2 new words to distinguish one leg from the other, but we'll work on that next semester sometime, okay? So for now, you gotta know where the hypotenuse are, and the other 2 are just legs. The gist of all this, you always classify by angles based on the largest angle inside the triangle. So if the largest angle is 86 degrees, it's an acute triangle. If it's 90 degrees, it's a right triangle, and then obtuse, of course, is obtuse. So let's classify these guys. Looks like they're all 60 degrees. What would that be? Equiangular, yes. Well, all these are just going to write the word right, acute and obtuse, and equiangular. All right, part B. What do we got? Obtuse. Why? Yeah, because that 120 is bigger than 90. All right, C. That one is right because of my 90-degree angle there. If you find this part hard, we might want to go back to 7th grade. All right, class for the triangles. Same idea. What do we got for the first one? Acute. Next one is obtuse. Riley, put it away. And next one is right. Hey, you're right. It's right. Not really. You're being obtuse. No, it does not mean fat. If anybody, and if we're gonna call anybody fat, it would not be Riley. We're not going to, but it would not be Riley. Okay. Classify triangle PQR. Oh, by the way, this guy right here is the triangle symbol. Remember how I promised you or symbols in geometry look exactly like what they're talking about? Yes. So it's triangle PQR. Triangle PQR. Acute, right, or obtuse?
Obtuse.
Why?
Because 45, 59 is at 90.
Okay, so that one is 104 degrees. So it is obtuse. Wait, I get lost in how many A's and U's there are. Because angle PQR is obtuse. What? Yes, it's obtuse. Because angle PQR is obtuse. All right, questions so far? No. All right. All right, now classifying by side lengths. An equilateral triangle is a side with all sides congruent. Again, sounds exactly like what it is. Equilateral, lateral being a side. All three sides are congruent. What? Yes. Angles versus sides, not to be mixed up with ninjas versus pirates. Pirates win. Viking versus pirate? Pirate.
No.
Yeah, pirates have blunderbusses and guns and stuff, which trumps armor. Pirates are skinny because they can't. What? Okay, get back on track, guys. Focus. Equilateral triangles have all three sides congruent. Isosceles, this is important. At least two sides are congruent. That's important because, well, what's the implication? At least two sides are congruent? Yes, it's isosceles, but if I say at least two, what am I allowing for? Yeah, in equilateral triangle, a third side being congruent is also isosceles. Okay? So an equilateral triangle is just a special case of an isosceles triangle. Now, the reason that's important is because I will be teaching you guys sometime this unit properties of isosceles triangles. We're not going to directly say, Riley, put it away. I will directly say that, actually. We're not going to directly say that that all these properties also apply to equilaterals. Because equilaterals are isosceles, they do apply. Okay? This actual verbiage right here of saying at least two or at least one, that sort of thing is actually going to come in important when we come to quadrilaterals. it's the whole idea of an equilateral is an isosceles, which is a triangle. You'll get the whole thing of a square is a rectangle, which is a parallelogram, which is a quadrilateral. And we'll get into that whole hierarchy there. There's actually a place where there's been a centuries-old debate because of a phrase similar to at least two. And it comes to the definition of a trapezoid, and we'll get into that later on. Is a trapezoid have exactly one set of parallel sides or at least one set of parallel sides, which can cause some problems when you start looking at different types of implications from it later on. All right, but we'll come to that in 2 units from now. All right, vocabulary. A scalene triangle is a triangle with no sides congruent. Stop leaning back in the rolly chairs. You crack your head open. They're assuming. Okay, no sides congruent. So, when I go to classify a triangle, I want to classify it using both a word for sides and a word for angles. So we could have an acute scalene, we could have an obtuse an obtuse isosceles, an acute isosceles, yes. We got to use both words. All right, so first off, acute, obtuse, or right? Acute and isosceles. All right, what about this guy? Okay, so if it's equilateral, the only option is for it to be acute. Okay, and because equilateral means equiangular. We'll cover that in a second. But yeah, so when it's equilateral, you can just say equilateral and be done with it. All right, what about C? Obtuse. Scalene. No, not saline. So, isosceles. Oh, I forgot to tell you my joke about isosceles. It's really bad.
Here we go.
All my jokes are bad, I know. But I am a dad, so it's okay. So, there's a lady who grew up in America. She's American, but she finds out that her ancestors were Greek, so she's of Greek origins. And so she really wants to infuse a little more Greek into her life. So she gets pregnant and she finds out she's having a boy. So she wants to name her son with a good quality Greek name. So she goes to a textbook and she finds a good quality Greek name and names her son Isosceles. You're supposed to laugh. What?
What did you say?
Wait, is it similar to that?
Yeah.
Involving medical terminology? Oh. Hold on, we'll come back to it. Let's do it after the recording. Actually, I really doubt that story's true. It was told to me as if it was true. But I doubt it's true because I've heard another version of that in which a woman did that, but she named him a different good solid Greek name and named him Testicles. Don't do that. Don't do that. No, could you imagine being that kid though? First day of school every single year. Teachers going through the roll. They call the kid before you and they're like, John Adams, and then they get to the next, and they're going to pause. They're just going to be like, and then this kid every single year is going to raise his hand and be like, yeah, my name's TJ. Just call me TJ. All right. Example 5. Triangle FGH. Let's come back. Let's come back to it. Triangle FGH is an equilateral triangle with FG equals x plus 5, blah, blah, blah. Find x and the measure of each side. So, if it is equilateral, what does that mean? So how do I solve for x?
You put them all equal to each other.
Or pick 2.
Or do that.
So x plus 5 equals 3x minus 9. So now, what?
You subtract the x.
Subtract the x gives me 2x equals, well, we're also going to add the 9, so that gives me 2x equals 14. So x equals 7. It's not what you got? Okay, so we asked for the first one, or I'm sorry, asked this for x. It also wants the measure of each side. So we're going to do FG is, well, 7 plus 5 is 12. GH is 3 times 7, and 3 times 7 is 21, minus 9 is 12. Good. They come out to the same. And FH, 2 times 7 is 14, minus 2 is 12. Well, good to check because, you know,
Wait, so if
make sure they're all right.
it doesn't say to like, so it's like it's not asking if it's an equilateral. Wait, they just pick one of them. Can you just put the rest of them instead of actually having to solve them?
Depends on what the question's asking for.
Yeah, that's why I said like if it's not asking for you to show that it's equilateral, but not actually giving you the information at first, it is.
Okay, I can't answer the question directly. That'd be a very case specific thing. I mean, answer the question they're being asked. That's the best thing you're being asked. That's the best thing I can say. What'd you say, Ryan? I thought you asked a question. Oh. All right. Okay, if point M is the midpoint of JL, well, if M is the midpoint of JL, I know two things. First off, JM is congruent to ML. I also know that since JL is 1.5, 1.5 divided by 2 is 0.75 on both of those. All right, so is triangle JKM, which is the big triangle, equilateral, I'm sorry, another big triangle, the small one on the left. Is that equilateral, scalene, or isosceles? Okay, so if this is 0.75, then this one right here is also 0.75, so it's equilateral. Because all three sides are 0.75. Now, justify or explain your reasoning is basically just a scaled down simplified proof. How did we get there? What did we do? So, since M is the midpoint of JL, then JM is equal to ML, which equals 0.75. And then we know that KM is equal to JM is equal to JK. So triangle JKM is equilateral. Sorry guys, my pen's being weird. It's like I'm not dragging my pen across, but it's picking up the stroke anyway. What?
You just want to give you a high five because you have to me last time. Yeah.
It says, since M is the midpoint of JL, then JM equals ML equals 0.75. Then JK equals JM equals JK. So triangle JKM is equilateral. Yeah, so KM, this one here, equals JM equals JK. And therefore the whole thing is equilateral. Got distance formula and stuff in there too, though. Okay, so an exterior angle versus an interior angle. An exterior angle. Guys, I'm getting really tired of talking over you while you have your own conversations. If I was to take a side and extend it beyond the edge of the triangle, that would form an exterior angle. So here, angle 4 is an exterior angle. 1, 2, and 3 are the interior angles. Okay? So, the remote interior, well, what does the word remote mean? Remote does not mean control. It means off in the distance, away somewhere, right? Not next to. So, from angle 4, angle 2 is beside angle 4. It's adjacent to it. Angles 1 and 3 are remote. Okay, remote interior angles are something we're going to have to deal with here in a second, all right? So, first off, we just need to know what they are. All right, so if I draw this triangle, which two are the remote angles? Angle 1, 2, or 3?
3.
Yeah, 2 and 3 are the remote interiors. Okay. You know what? I put this in here. I'm not going to actually do the lab. It's because I don't want the YouTube students to feel left out when they can't use the lab reference.
You should ask them a daily question. Like, put it in the comments.
What did you learn from today's lesson?
No, like, what
Geometry
kind of food do you
stuff
want to eat at different times in Australia?
Y'all are not helpful. Okay. So, shh. Triangle angle sum theorem. The sum of the measures of a triangle is 180. Y'all know this, right? Add all three together, you get 180. So, the implication from that, if two angle measures are known, then you can always find the measure of the third by subtracting them from 180. Simple enough. All right, so let me show you something that I need you guys to not do. Okay? I realize it's dangerous to start off by showing students what they should not do, because then they'll do that. But some of you are doing this anyway. Okay? Here's what I need you to stop doing. 25 plus 35 is 60, and then 180 minus 60 is 120. Boom, done. Why? Because this sort of scattered arithmetic on a page is what you did in elementary school. It does not translate well into higher order mathematics. As you guys are getting ready to go up into Algebra 2 and pre-calculus and calculus, I need you guys to start getting used to writing things out using proper algebraic notation on things. Okay? So, the way that this should be written is something like this. Measure of angle T plus 25 plus 35 is equal to 180. Then we got the measure of angle T is plus 60 is equal to 180. Then the measure of angle T is equal to 120. Notice I did all the exact same stuff in those two. However, this is scattered calculations. This is written out, organized, and nice and proper. I can follow exactly what you meant on this one on the left. This one, I'm completely dependent on, did you write things, like where on the page is it? I'm having to scatter myself around. You like it? Well, stop doing that. Don't do that anymore. It's so much easier, but you've got to mature and grow up at some point. Okay? Okay. No, you are not Peter Pan. That one guy is Peter Pan in the Starcatcher or whatever. 2 weeks. Yeah. Yeah, that one. Peter Pan and the Starcatcher. And the Neverland You Never Knew. October 24th to 27th at 7 p.m. Come watch. Buy tickets. All right. Find the missing angles. We're going to start with 1, 2, or 3.
1.
Why 1?
Because we already have 2 angles.
Yes, not because it's number 1, but because it's one we can actually deal with. So measure of angle 1 plus 90 plus 58 is equal to 180. Measure of angle 1 plus 148 equals 180. Therefore, measure of angle 1 equals 32 degrees. All right. Now we know that the measure of angle 1 is equal to the measure of angle 2. Because of vertical angles, so measure of angle 2 is also... Now, if you're writing a proof, I have you write reasons.
The reason is
the reason is Mr. Love said so. Yes, that's exactly it. Okay. All right, so now measure of angle 3 plus 32 plus 108 equals 180. Measure of angle 3 plus 140 equals 180. What is going on with my pen? No.
Don't slow down. This quick is like basic.
All right. So now, measure of angle 3 plus 140 equals 180. Therefore, measure of angle 3 is equal to 40 degrees. All right. Exterior angle theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two remote interior angles. So, let's think about this. These two angles here, A and B, when I add them up, don't they have to be these two together plus that one? Doesn't it have to equal 180 degrees?
Yes.
Which is the exact same thing as number 1. 1 plus angle BCA is also 180 degrees. Because of that, angle 1 has to equal the sum of angles B and A.
Oh, I get it.
You can't say it's 60 because I have no angle measures at all here. Oh, number 9. Okay, well, let's get there. Okay, can we say that it's 60 because of corresponding angles? No, because we don't have any parallel lines here. That would work if there's parallel lines. So, here's what you do. You add those up. Measure of angle 1 is equal to 80 plus 60. So the measure of angle 1 equals 140 degrees. Done. Now, you could do that the long way. You could say 60 plus 80 is 140 minus 180. gives me 40 degrees, and the 180 minus 40 is 140. You get the same place. All right. No, angle 1, you add these two together, and that gives you angle 1. Yes. Okay, 10. I want to find x. Well, 78 is an exterior angle. Angles S and R are the remote interiors. Guys, cut it out. And so, 78 equals 55 plus x. So x equals 23. Yay.
Lemon squeezy. Squeeze the lemon.
All right, last one. All right. So let's do, first off, I'm going to find the measure of angle 3 first. Because I feel like it. All right, let's see. Angle 3 is an exterior. So I'm sorry, let's look at this triangle here. Triangle TUV. Angle 3 over here is an exterior angle, right?
Yes.
So, what are the remote interiors?
35 and 36.
So it's 35 plus 36. So measure of angle 3 equals 71 degrees. So, measure of angle 1 plus, through our linear pair, so plus 71 equals 180 degrees. So the measure of angle 1 is 109 degrees. Okay, so here's what I did. I used the remote interior angles. I said that angle 3 is equal to 35 plus 36, because this is a remote interior. Then, I know these two are a linear pair, so they add to 180. So angle 3 plus angle 1 is 180. What dot? The degrees, technically, yes, it's wrong. All right, now, this guy over here is also 71 degrees because of the vertical angles. And so measure of angle 2 plus 80 plus 71 is equal to 180.
Oh, I did something different.
What'd you do?
I was going to use 2 as an exterior. Wait, can you?
No, you can't use 2 as an exterior because you would have to have a line that comes all the way out for that. Now, another way you could set this up is you could say the angle 1 is an exterior and 2 and 80 are the remote interiors. Yeah, so I mean, you could also do measure of angle 2 plus 80 equals 109. But honestly, when you look at that, that is almost like another algebraic step coming from this other one, right? Because if I subtract 71 from 180, I get 109. I mean, either way, it doesn't matter. As long as you're using a valid property to get there, I don't care. Okay? So then, measure of angle 2, subtract 80 gives you 29 degrees. So, that's it for today. We got a homework assignment for my local class. All my YouTube people, yes, I want you to do this. Pick up any random book you want in the world off the bookshelf. Go to page 242, do those problems, and yeah, let's see how well that works. All right, anyway, that's it. As always, guys, stay patriotic.